Right, we'll make a start then. So thanks everyone for joining us for the May Electrical Safety Community monthly call. Go through the housekeeping. So if you're registered, you will get a recording sent after the call is finished. Please use the post-call survey. Let us know we're working on the right subjects or anything that you want covered in the future, or even just to give general feedback. Or if you'd like to get involved, again, put it in there or the chat. Make use of the chat as we go, and we really actively promote using getting involved and participating in the calls. So if you want to speak, just raise your hand and Ben can unmute you and you can give us your experiences, uh, challenge what we're saying as well, because it might not always be right. And after each session, we will circulate the slides, so you will have those sent through as well. So just a brief introduction. We had a conference, for those that weren't at the conference, we had a conference in October last year. We had lots of good ideas and collaboration going on between who would typically be competitors, but people from the data center community and others. And essentially, at the end of the conference, everyone goes home and gets on with their day-to-day business as usual tasks and loses that focus that they had in the drive that they do have in a conference environment. So we've tried to move these forward, meet once a month, and we've got established a steering committee, who you can see here. We've got a shortened version down today, but essentially it's going to be the steering committee's role to own the work streams that we've got embedded within here, and then sort of drive the objectives within those work streams. So just to recap, we run these once a month. It'll be a 1 hour call. The steering committee will go through the work streams. There might be key topics within those work streams that we might delve a bit deeper into, share, or ask you to share some of your experiences. That'll be great. If anyone would like to share anything relevant that you guys do, which is in line with the work streams around electrical safety, and they cover quite a wide base. So if it's something that you're proud of that you've done in your workplace, or something you've done and you're not so proud of that hasn't worked too well, they're how we learn. If someone's made a mistake somewhere or you've tried something thinking it would improve stuff, it would be really good to pass those experiences on because that's how we learn from each other. And often they stay really insular within the organization. So the purpose of this is really to try and share that information out and so we can all learn and grow and make the workplace a bit safer. So we will recap on the work streams. The community are all volunteers from their own individual companies and they'll give their experiences and their knowledge. We'll open up to you guys then in the community to get your feedback and we'll review this each month. The aim would be we have got a conference happening, Ben. Is it October 13th?
October 13th, yeah.
October 13th. So we'll send some information out about that. But 13th of October, we'll have a follow-up conference in Chantilly, Virginia again. Same venue, different location within the venue, but probably even better this time. And essentially, it'd be really good to look at what we covered in the conference, what we've discussed as a community around this, and then just see how we drive this forward. Again, I don't think we're going to change the world in 12 months, but it would be good to make sure we're working and identifying the right things within there. So a safety moment, it was Wayne was going to volunteer to share one today, but unfortunately he's off sick. I don't know what's taking that guy out because he's an absolute machine. But yeah, we can fill in for him. So this is a an incident that has occurred on a industrial site in regards to some withdrawable switchgear. So this is a 11 kV withdrawable. This is actually an oil circuit breaker. So the incident was during an outage. The equipment was isolated by the customer, so the equipment owner's authorized person. So the isolation was conducted as you would expect for the competent person or the person in charge of the work that's conducting the work. This was for some maintenance on the cubicle itself for the circuit side. So that would involve, as you would expect, it's been isolated, so it's been disconnected from the sources of electricity, and then because it's medium voltage, because it's yeah, so it's 11 kV, we needed to ground that circuit down as well. So for this type of gear, you would put on like an extension, a grounding extension into the spouts, and then apply your portable ground to the substation grounding arrangement. So essentially, the equipment's been isolated or apparently isolated. the customer's authorized person has shown the competent person that's going to be doing the work, the isolation, and then compared that to the one line. The one line shows everything's isolated as expected. And then when the competent person then is going to fit the ground extensions, the circuit has a secondary supply, which has resulted in an arc flash incident. It was quite quick, but you can see there on that spout there that there's been damage from like that carbon where that arc flash has occurred. So the incident details were that the single line diagrams weren't correct. It didn't show the secondary supply. The equipment design. So these are lockable shutters. So again, they should have been locked and then only opened at the time that we'd done the last stop, which is probably the most important, that live dead live process not followed. So had they even been shown it and fully believed everything was correct, they should have done their live dead live check prior to actually inserting any tool into that orifice. So yeah, the guy's been very lucky in this incident, but it shouldn't have happened if they'd followed this process. Anything to add on there, Jose?
No, the single line diagrams being incorrect is pretty common, unfortunately. Unless it's a new design, like unless it's a brand new build and you just had commissioning and construction leave and they just passed you the prints. But if you're an existing facility, 5, 10 years old, you're an ancient building, and having correct or even updated drawings, I mean, you'd be lucky.
The
Somebody,
this equipment's quite dated, but the end so the switch gear is quite dated, but downstream there'd been a project where they'd gone from a standard MV to LV transformer and they'd gone with a dual winding like secondary going to two LV air circuit breakers. So there was one isolated and then one that wasn't isolated. That was close coupled on the wasn't close coupled on the transformer. They just assumed it came off the one circuit breaker that was on there. So it was a backfeed supply, and then obviously it stepped up from LV to MV to back onto the circuit orifice there. So it's again that equipment design, and then not updating the one line at the end of the project, which is quite common. I suppose another one around this is as I've been kind of looking at differences between UK/Europe and US differences, is on this type of gear. Pretty much everything in our region is lockable in terms of shutters, whereas I see a lot of the US equipment in terms of design doesn't come with a sort of padlock arrangement, so you can lock your circuit shutters or your bus bar shutters. So again, it might be something that's possibly more common if you haven't got that capability of locking it, in line with the design. Am I right in thinking that, Jose? Or is that just
yeah, no, you're accurate. I've seen a lot of UK, Europe uh, switchgear, switchboards as well, and they're excellent from a from both grounding and lockable status. I'm not sure why we manufacture it less,
Yeah, I
but
think it's just go you just if you're just repeating the same design, isn't it? And you're not getting told anything's, it's about that constant feedback loop, isn't it? Like, is it
mhm.
fit for purpose? Could it be made better? And if there's no need for doing I suppose any further development, then just yeah, but I suppose it's something to consider for anyone on the call that's got this type of gear. So jumping on again because Wayne's off. The work stream one side is around commissioning, transition, and turnover. So this was around because it's such a high risk phase. Wayne's really passionate about it because it's his bag. But it's that first energization, temporary systems, temporary power, and then obviously that handover process from where it's transiting from the commissioning side. So a big bit of this is around making sure we've got the right information to check and verify as we're going through that process. And Wayne's work stream are looking really to try and standardize the turnover document so that I know it's going to vary from customer to customer, but the equipment's pretty much the same. It's going to vary slightly by design. So if we've got a standardized process that is deemed best practice, that's kind of what we're looking to reflect on and agree between us as a whole community that we can potentially utilize. So one of the steps that we're looking to do is focus it down from an overall handover or turnover document to individual items now. So that's going to be worked on over a number of months moving forward. So I'll just ask anyone on the call if you've already got any processes around commissioning of individual electrical equipment or transformers, switchgear, uh, PTs or VTs, LV switchgear, transfer switches, things there, all the stuff that we would typically commission in your commissioning phase of a data center. If anybody's got anything like that as a starting point and wants to be part of the working group as well, that'll be really good. But that's the process that's going to follow. So something that Wayne's kind of put in here is just some examples. And they're quite thorough, the things that he's kind of put together. So this is just based around switchgear, essentially in the first instance. He will be putting it into a tidy document that when we agree upon the format, but it's things like this is kind of the level 2 side of things, so where it's gone from the factory acceptance test should have already been completed in level 1 again, which I think he's got a draft template of. But this is all the stuff around making sure that the equipment's intact, none of the existing labels or tags have been damaged or tampered with. Basically everything that's correct in its place. But these bits are kind of the most important, and I think as I went through these with Wayne, and I think if these are done, the questions that we asked at the last conference was who he has had an arc flash on first energization in the last 12 months. And the number, I mean, you were there, Jose, it was phenomenal, wasn't it? It was quite a lot of hands raised. And if we're following something like this, things like typically it's a mechanical issue that's caused this because electrical is always great, as we know. But things like torque checking connections, checking those marks, making sure they're in the right place, continuity tests. I think if we're doing those plus our ductor tests on the bars, if there's good contact, you're probably still going to get low resistance, which isn't really going to identify an issue. I think the mechanical check is your visuals and your torque checking of connections or pull tests of control cable and things like that. But all these tests, I ideally should pick that up. Partial discharge test, fine, but that would really be after first power. You're not really going to pick anything up when it hasn't been energized yet. But if all of these things are conducted, they should significantly reduce the chance of flashover on first energization, which don't see any reason why we should still be having them if we're following something like this. Is there any feedback on this initial document before we move on, or anyone that would like to add anything on top of this?
There's a hand raised here, Dan.
Yeah.
I'm gonna unmute you now if that's all right.
Hey Dan, just real quick. The only thing I don't see is just PQM guidelines. We sustained an incident within the past 30 days or so, and where an individual at the PQM was hot swapping the leads that double insulated. It's supposed to be finger safe, but if you have a sweaty palm and you put the tip of that lead into your palm, you can get nailed. And I think it's worth sharing with everybody when the IE, who's still alive and well and doing well. He had some burn marks on both of his hands. He had an A phase and B phase in his hands. Long story short, I asked him. I said, "How did it feel?" Like, well, scale of 1 to 10, and he said 11. And I said, "You're an electrician." I said, "You've been doing this a while. I'm assuming you've been hit before." And because I kind of I thought maybe it wasn't that severe, and he said, "I've never been shocked like this." And on top of being hit, he also suffered, and I've never dealt with this, he suffered a fracture in his shoulder where the ball joint actually sits in the shoulder, a depression fracture from how hard and how violent and his muscle contractions were. And so
Wow.
I think it's something that the industry hasn't really talked about as much as we need to, and it's a hazard, and I think everybody knows about it, but I think we got lucky. And so long story short, it is 100% de-energization to do any kind of swapping of leads. And we've made a very easy path, simple lockout, tagout, controlled, by the commissioning team, etc. If they do, and I'm talking strictly on the PQM side, if they have to go into the cabinets, break the plane, everything has to go, through the energy marshal, full blown lockout, tagout, etc. But we're trying to meet them in the middle because we just don't want anybody ever hot swapping leads like that again. And just I figured I'd share that with everybody.
No, it's really appreciated, Chris. I mean, on the next call next month, I mean, you obviously take out anything that's client based, but would you be able to present something around that just to
Oh
give a bit
yeah.
more context? Would you mind doing that for our safety moment next month?
Oh yeah. No, we've got a couple things put together on this one. Yeah, I'd love to.
I appreciate that. Thank you.
Mhm.
Has anyone else got anything to add on workstream one? If not, we will press on. So workstream two, this is around energy control plans. I can see we've got Daniel Furbush on from Auto Lotto, so someone that's quite heavily involved in um, pushing for this type of arrangement. So this is really, I mean, it's quite a wide topic, but it's around all the identifying the difference between our energy control plans, our lockout and tagout processes, and obviously we've got multiple stakeholders involved in that. So we've dependent if it's an operational site, construction site, number of contractors, who's in control of contractors, things like that. So part of it when it first started off, Wayne and Alan were looking at things like gap analysis of different electrical safety programs when you've gone from client to GC to ECs, and then trying to make sure that they all align with that minimum standard and there's no real discrepancies. So Wayne likes to utilize AI tools to do that, to identify those differences. But again, it's many roads, one destination. We just want a safe process to be in place. Um, and another thing that we were looking at was where those control boundaries exist. So where it goes, if it's an extension or if it's already an operational part of the network, and then we've got construction going on, there's key risks around that because obviously we've got an energized network. So all of these areas are kind of high risk, which is why it forms part of the this lockout and tagout part of the process. So essentially, what we're looking to do here is again try and gather data around the best systems to use with their advantages and the disadvantages. So one of them is going to be we're just going to try and gather data around who's utilizing digital tools, who's not using digital tools, what's the advantages, the disadvantages, and then I suppose, try and document that. So the aim would be for the committee to put together a white paper. So if anyone's thinking about going down the digital lockout tagout route, that they've already got some information there ready to go, unbiased, with some clear advantages and disadvantages of both types of system, or even a hybrid. So that's the aim. So again, we invite anyone that has got experience in that to support part of that. So one of the questions is, who on this call uses a digital lockout tagout system? If anyone on here now has one, it would be great to get a bit of feedback. And if anyone wants to be involved in this, also I'd appreciate that.
Should we launch the poll then?
Oh yeah, if you've got a poll,
Yeah, yeah.
set it away.
So yeah, all up and running now.
And this was one area where we added a bit more. So we spoke about some benefits in the past. Really, it was more the benefits, and we didn't really have a lot of time to challenge the challenge the like with some disadvantages. We have offline, but I think again it would be good probably to have another session in future, just to maybe with one or two people that either use it or supply it, and go around what some of the disadvantages are and give us as a community. Because I've never used a digital tool. I love a bit of paper. Jose, I'm not sure about you, but I think it would be good to maybe rerun that and give it a bit more time. What do you think?
I'm definitely an and person versus an or, as opposed I want both because I love the digital process because it does streamline things and it makes things instant across the GCs, across different teams. Like it's immediate. There's an immediate benefit to having electronic. And I see that in the training side too, where like if I were doing an assessment, even a practical assessment, like person to person, and I'm training someone to do an operator to do something, if I had an electronic tool, I can grade him right there. His chief can see, his manager can see, like a whole the dashboard, like the leaderboard, everything can get updated immediately. So like the fact that you have an electronic system that can go across the entire org, instantly is awesome. Now, to your point, Daniel, the shoe falls, right? Like when Wi-Fi isn't working, when the app is down, like you lose it. Like you lose your ability to grade, you lose your ability to, track what you just did. So you still need paper. Like I think you need to train on both. I think you need to have an electronic system if you want to be up to date and get everybody on board. But I think you still need to train when this doesn't work. Here's a paper version. Because I've seen that in other industries, the hospital is the same way, super electronic. Everybody's doing their rounds. They're checking on patients. They're using a little, iPad. But when that doesn't work, they have to go back to paper. And no one's ever seen a paper. No one ever done this, by hand. And so you need to have both. Like to your point, Daniel, like paper doesn't go away, but paper isn't instant either at letting everybody know, what the status is.
Yeah, no, yeah, I fully agree. I think the benefits are there. It's what's the disadvantages, isn't it? I think if you've got a big network, costs obviously will come into it for anybody.
Hmm.
And you're building a digital twin essentially on you, which but yeah, I think it's definitely worth looking at. And it's really interesting to see there the partial ones as well, where it's maybe a combination of the two. So I think we'll plan that in maybe for next month or the month after. Ben, we'll try and open that up to get some feedback and maybe get maybe a provider or a user or
Hmm.
both to talk through those advantages, and we can maybe come in and be the grumpy guys and challenge that to find out how it actually works.
Yeah, sounds good.
Perfect. So that's kind of work stream two, I guess, what we're focusing on. We'll come to the other bit, which ties in with those at the end, but essentially that's going to be the main focus is working on that paper as a team, as a community. Hopefully you guys will want to be involved in that. Work stream three covers arc flash electrical hazard management. So again, why? Because it's high consequence. But obviously, as we're moving from this covers, it's so wide again, it covers from the construction side where we've got ever-changing networks, partially energized networks, temporary power, right through to operations. Um, so essentially, there's going to be potential changes, especially from original design when you've got assumptions built in there, cable lengths differ, things like that. So you're gonna have different impedance values and stuff like that. So things are going to change as we go through that process. So the whole thing around this is identify how we manage that throughout that whole process. So again, if anyone would like to be involved in that around how you manage it at your site, what experiences do you have? So whether it's temporary label methods or do you have set stages when you review the model, or do you have consultants that review the model at set stages initiated by the client or the EC or GC? It would just be good to know what you do, what those phases are through this process, and how they differ from everybody else. It'd be good to have an aligned process. Typically, it would be, I suppose, either set points or significant change on those networks. But again, I'd be open to know when those are and what those mandates look like around equipment labeling. Um, but again, we need data on this. So we know we're getting issues with Arc Flash, especially in first energization. So when we go into workstream four, we'll kind of follow this up with the kind of data that we're going to be looking for. But a key part of this, one of the things that we are looking to do is as a committee, we're working on an overall electrical protective clothing and PPE policy to see whether this is achievable. whether it's going to be done by geographical region or whether it can be done in a global manner. There's a lot of differences globally, especially in terms of voltages, standards, things like that. But definitely achievable because some people do it. So we've kind of made a start on this, and it'll be sent out again to everybody, but that's registered for the call for feedback. And this is something that we'll review a bit further in detail on upcoming calls. But essentially, what we're looking to, some of the points we're trying to include in there, the reason why is obviously we work with quite a lot of different organizations, different, maybe not just data centers, different industries. Obviously, we can all learn from each other. That's the whole point in these calls. We're trying to collaborate and stand on the shoulders of giants because there's a lot of good ideas out there. So I guess the whole point is that when these hazards exist of electric shock and arc flash, we've got to mitigate them to keep our people safe, and we have to have PPE measures. There's loads of different PPE options out there, and when I'm speaking of, even when I was, not with Scanwen, I was working in either projects or as an engineering manager or a senior authorized person operating the networks. They varied from product to product, customer to customer, site to site, and some of them, it was just it wasn't clearly defined. So you just had this sort of disparity all over, and I'm sure it's not a one-off situation. I'm pretty sure we find this everywhere. And then same thing around the differences in the product. So cost is sometimes a factor. So people might go with treated fabrics, and then like quite arduous conditions. They're washing them in harsh conditions, not knowing the differences between inherent fabrics where you can kind of just wash them in line with the manufacturer's guidelines, things there, and make sure you've got the right level of protection. So that the aim of it is really to try and identify a minimum standard so that as we're going into either projects or operations, as a client, we've got a minimum expectation of what that PPE looks like. So again, got some definitions in there, just that's included in there. One of the big points of contention, and please either you can throw it in the chat now, unmute, or just send it back once we've sent the actual document out. But who it applies to, and on the working part, Jose, again, I don't know if this is probably your first time looking through this, but work on electrical equipment and work in the vicinity of electrical equipment. So work on, again, we've identified it, putting in as applying to low voltage systems where tasks require making contact with exposed energized electrical conductors or circuit parts, blah, 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 which includes testing, troubleshooting, taking measurements. So again, because you're likely to do it on LV, I've put in there that live works on medium or high voltage is prohibited until suitably isolated, locked and grounded to prevent the incident we spoke about in the safety moment. And then work in the vicinity of electrical equipment. So this is where you might be doing non-invasive work within a substation, transformer compound, things like that. But you're within the restricted approach boundary. Have you got any feedback on that, Jose, or anyone on the call? Does that kind of ring true? Or any situations outside of that doesn't meet that criteria?
Give me a second. I'm digesting the obviously the second one. You're in the restricted approach boundary. You need PPE. That's you're there. You're looking at it. The bears, there's a problem there. Working on electrical equipment that
So this is
require
typically when you're
entering.
on the equipment, you're
Mhm.
you're interacting with it. It's invasive essentially, which you would only really do on LV and typically under the terms of an energized electrical work permit.
And so that's opening a panel, right? Like opening a switchboard
Yeah.
to look.
Well, to work, anything that can involve tools, testing,
What was energized?
getting your mitts on
Yeah,
there.
yeah, okay, so how much PPE is always the case? Or like if you're going to be working on anything electrical, it is prudent to have electrical safety gear, right? It's prudent. It's smart of you. Like you're working on electricity, doesn't matter if it's a little bit, doesn't matter if it's a lot. Like
Yeah.
it's prudent. You should be safe. Uh, this is where NFPA 70E like calls it out. These are the general requirements for this voltage versus that voltage. But if you're
Some of the
trying to make a
differences in voltage,
yeah,
obviously, some of the differences are US would be LV 600 volt, UK 1000 volts, well AC. Um,
mhm,
and then, in that definition between low voltage, medium voltage, high voltage sort of thing. So, because a lot of the equipment, things like, so low voltage might be 600 volts AC, but a lot of generation, so things like wind turbines, solar, like PV, a lot of that generation's at like 690 volts AC. So already it creeps into that MV category within the US, whereas in UK, Europe, it would be in the LV bracket, because it's under 1,000 volts AC.
sure.
So it's, I don't think that's something you could pin down voltage levels within a global document unless you define the differences between there. But yeah, it was really defining work because in most documents it'll define work, and I think anything outside of the restricted approach boundary, you could make a risk assess process around whether people need to wear arc flash PPE. So if you had people, I don't know, painting a substation or um, putting up lights, things like that, as part of the general mechanical infrastructure, things like that. Would they go cleaning? Would they go to the extent of purchasing, PPE, the cost, things like that against that risk? Or so do you just define work around being in the restricted approach boundary, and then work on obviously being on the equipment, whether it's
Hmm.
energized or de-energized? Have we got, I think there's some comments in
Yeah,
the chat
yeah.
there.
Just one. I'm gonna unmute you now, Kevin, so you can speak.
Okay. Yeah, can you hear me now?
Yeah, we got you.
Okay. Hey. So I know we've struggled with using low, medium, high voltage. Uh, and it also depends on if you're using NEC versus an FPA 70E. So I would prefer that, you whenever you're writing these type of things, you're actually calling out what voltage uh there. If you can, or if you need to like kind of define your voltages in another definition, then you can do that. But I find like it gets really complicated when you're talking low to medium to high, depending on where you're
Yeah,
located.
agreed.
And then, so risk assessment. So switching, you'd want to refer for us in the US would be your NFPA 70E, and then your risk assessment. And then you look at the likelihood of arc flash, which is, I think, 130.5 in the NFPA 70E. And so then you could risk that out and see what the likelihood is there too. And then I'm not sure if we bring in anything as far as condition of equipment in this definition and if it's been maintained or not. Those are my two
Yeah.
cents.
No, not
That's a great, Kevin. I agree with definitely explicitly naming the voltages. That'll that'll change that'll help. So love the numbers. Uh, and I agree. Like NFPA 70 does call out the maintenance part, in good condition, all doors closed, etc., for PPE selection for the risk assessment. So agreed.
yeah. No, that's good. Have we got any other comments on there?
No, I think we can keep going.
Yeah. Um, yeah, so we've got some definitions. Again, that's the difficulty around definite, like the defining side, things like voltages that change by geographical region, things like that. Again, not going to go through these. We'll send it out, but some of the general requirements or what we would expect the minimum protection level to be. In Dayware would always be the preferred method, so that if you're going into if something arises, you're not going to have to go away to put on your gear, that you've already got a level of protection there. A big point here is the inherent materials only. And again, this is just to go away from, if it's a procurement exercise, procurement is always going to go with the cheaper option, which would tend to be treated. And again, it's that having an understanding that it's definitely protecting the worker, and that's it doesn't matter how they're looking after the product, as long as it's kind of in line with the label, they're not going to reduce the protection side of things. Proper coverage, again, that's just as expected. Where the levels come from, so hazard labels, where you haven't got any instant energy data, so when we use the table method, and then just additional processes around what you'd wear underneath, so you haven't got any additional fuel, what you'd wear with it. And then one big point again is any branding or logos that they've got to be flame resistant, not damage the integrity of the product. So just I'll send this out for feedback. We've got some stuff in there around non-conductive equipment, being clean and maintained in line, and that we're doing suitable inspections for damage, contamination, or defects before each use. Then we're covering things like footwear, eyewear, gloves is always a point of contention. So testing your gloves, pre-use checks on your gloves. Again, a common thing that people might do is inflate them, fold it over, and make sure that it doesn't leak, because people don't tend to go around in the field with glove testers and pump them up. I mean, they might do, but it's not something that I see very common. So it's just having a process that you follow for testing your gloves before use. Again, what you do, and it'll be good to get feedback on what you do once we send this out. Find out, are there any differences, any best practice things that are done by your companies. Yeah, and then obviously the differences between whether the system's energized, de-energized, determining what task you're doing to determine what gloves and things that you're going to wear. And we've put an appendix in there, which is based on something we worked on with one of our clients. They use a tool for, so this is if they're going to a field, like a site in the field that doesn't belong to them, and they've got to then operate and or work on the equipment. They've broke it down by, so rather than going off the table method, they've got a quick calculator method, which takes into account the circuit, the protective device that's fitted. So whether it's a fuse, protection relay, things there, and the settings to give them how many cycles, so how long that'll take, approximate trip times. So there are some assumptions built in there, but essentially it's I suppose it gives them this approach that they can take where they can either apply, an 8-cal layer, then layer up with different things, like it might just be a jacket or a set of coveralls over the top if they're doing certain tasks. So essentially, the 40-cal suit is great for what it is, but if you're doing an example, what's going to be, something that I supported was in the US was a 20 panels being isolated on a 28 panel board. It was in summer outside, red hot on a 13.8 kV switchboard in a 40-cal suit, isolating 20 breakers, and then going to the rear of the panel to remove 20 rear covers with a tool, and then discharging the capacitance in the MV cables, proven dead, then applying your portable ground 20 times in that type, so it's great to know having a 40-cal suit for that, or the company safety person also wearing a 40-cal suit with a rescue pole, things like that. But obviously, it comes with limitations. So ideally, we would try and be as comfortable as we can. But again, we've included this in the document, which we'll send out after, and any feedback is, really welcome. Has anyone got anything to add on that?
I think we're all good.
Okay, and then finally, work stream 4 for Jose's bit. I don't know if you wanted to go through this one just to give me a break.
Yeah, everything we've been talking about, like all of these safety implementations in different phases during construction, during commissioning, during operations, when you've turned over a building to operationalist, all of this is great. And what we'd like to do is obviously just make sure that we are setting standards for the training that gets developed for which phase. And that's what we'd like to know. We'd like to know, are people messing this up in the construction phase? Are they messing up in the commissioning phase? Is it the service techs that are coming in during operations? Is it the operators that are responsible for maintaining and operating the building? Like, who's messing this up? That way we can ensure that they're getting the right training, getting the right experience, getting the right information, all of it so they can do better, so they can perform better. Like that's what everything comes down to is, we want you to be safe, but those are just nice words until you actually show them what safe looks like. And you also show them what safe doesn't look like whenever you don't do it that way. So that all being said, you got to tell us. Or like I have experience. I've come from nuclear background. I've done things, to the nth degree per procedure in the military, and then I get out into the real world and I find out that you don't have to do everything to the nth degree to a 50, step process to do something that takes 10 minutes. So speed to market, all of these things that somebody that wants to make money and be profitable, like they take to heart, but they don't necessarily put it together for the operations person or the technician. Like so they're of course pushing get it done faster so we can bill the client and we can get our money, as opposed to you being the technician who is actually going to put your hands on that thing. And so we want to know who's doing it right, and who's doing it wrong, not so we can go after the ones who are doing it wrong, but also so we can know who's doing it right, so we can get them up to talk, so that we can get them up to explain, hey, this is how come we do have a safety culture. Everybody's safe. That's just the way we do things because literally this is the way we do it. We write it down, we teach it, we talk about it, we bring it back up. We don't forget about it. We don't just do it once a quarter. We don't just do it once a year. We don't just send you to a safety authorized person, 1 week webinar and call it good, as Daniel just said. So this is for real. So all of that being said, this our workstream 4 is trying to get that information from you all, from whether it's you directly, like you're in charge of it, you're the EHS person, you're the director, who has this information in your organization, or you work in operations and you can get a hold of the EHS people that can give us this information. Like all of that helps. Even just your own experience helps during these calls because we can't. I mean, we're just one person trying to make sure that everybody gets the same kind of, can get the same kind of good standard information. So yeah, smooth is fast. Agreed. So that's my bit.
Yes.
It's share, please. Talk, share,
No, appreciate that. It's and
Yep.
obviously this is the Data Center Safety Council side of things. They're going to add that to the work that they're doing as well, which is, so hopefully together we'll have a finalized document where we can kind of so I suppose support needed. We're trying to benchmark we need to do a benchmarking exercise to determine industry electrical safety maturity. So we need to do this data gathering exercise to commence ideally over the next 12 weeks. So we're going to link it with all of the data gathering parts from all of the work streams rather than just work stream 4, which specifically looks at things like management of contractors, competency of persons. I mean, that's a big enough thing, as Jose has covered already, but ideally we want to look at things like arc flash incidents, including near misses, contact with electricity, also near misses. So you may not have come into contact, but it's foreseeable that could have happened and you might have reported that as a near miss. First energization faults, instant near misses for non-electrical workers as well as electrical workers, document gaps. So we're kind of working on, we started off with an initial questionnaire. We're going to build that out really to cover the other work streams as well. And then we'll send that out, and obviously, and as we're having these, we can have informal conversations or formal conversations, whatever suits best to gather the data. Through Scanware, we can utilize an NDA if needed. As we mentioned at the start, there's so many things that happen internally at companies, and then we'll raise it through a safety moment, communicate it out, and it just stays there. If it's happened there, it could happen somewhere else as well. So the thought around this is building that data to identify those trends, make sure we're working on the right thing. But additionally, it offers an opportunity to benchmark as well. I remember when I was at Rolls-Royce, in civil aerospace, I thought, we're doing quite a good job at what we're doing here. Our electrical safety program's quite robust. The incidents are reducing over time. So it's a good trend. But really, how good are we? I think we're doing well. There was no comparison, there was no benchmark for that. And I think if this could lead into a benchmarking by, industry, so whether it's heavy industry manufacturing, data centers, which is obviously this environment, if we can have that data where, we can have some approximate benchmarks, again, it would all be anonymous, and anything would be protected for you or your clients. It would just be really good to have that baseline information so that you can know if you're good, bad, indifferent, somewhere in the middle. Because typically with engineers as well, you either I'm really good, I'm happy with what I'm doing, or I'm really bad and I need to keep improving and I'll keep this to myself for now. This, it tends to be one extreme or the other. There's often no middle ground. I'm fine. It's so this is the support that we need from so if anybody's got anything on the call, anything they'd like to add to that, that would be really helpful. Or we will be sending out a questionnaire to follow. And if you wanted a session outside of this, we could go through that and help us identify the questions. You got anything to add in there, Jose?
No, I think you've covered it.
Too much coffee, sorry. And yeah, I think that kind of covers everything where we are. If there's anything, like I say, I think in the next session we'll probably do like a deep dive into an individual work stream and open it up for scrutiny. Probably the digital lockout tagout tools, whilst we're gathering the data for the other areas. So if you have got any of those parts that we've talked around and you want to share those, if you want to get involved, let us know. But are there any questions? Looking good.
All good.
Yeah, it looks good. And obviously, if anyone wants any information around the conference, we'll be sending that in the next week or so, Ben, do you think?
Yeah, definitely.
Yeah, so but it'll be good. Venues, we know the venue, we've got a better room, we've already got a lot of good speakers lined up, and we've got some great data from the work that we've been doing already. So be excellent.
Hey,
Not
Dan.
brilliant.
Chris mentioned earlier in chat that he left a call regarding 800-volt DC cabinets. How's Scanware doing for PPE and moving towards that direction?
For 800 volts DC.
Mm-hmm.
I think it's we're waiting on some data coming out around so we've been getting some modeling work done around arc flash. It's just very different, isn't it, from a
It is
DC environment to AC.
correct.
So there's a lot of conflicting data. So we're just waiting on, we've got some sort of work happening in the background around what that looks like because it's only going to go higher as well. It'll not stop at 800. Um, so there'll be a point where it goes into the HV category for us. So no, definitely something that at the moment we're just working off AC principles, but we are looking in the background at the DC side of things. Have you guys had anything to do with that?
I've seen it come. So I imagine that's going to be a topography from a power distribution standpoint to move to DC. I
Yeah,
mean, it already has moved to cabinets using DC, and there's some data centers, some companies that already exclusively have always used it. So I think it's just coming into the limelight. But I do know that it's mature, or like the AC arc flash PPE and program is mature as opposed to DC. DC is not as common for everybody to know about. So I'd
yeah,
be very curious about I'd be very curious about the testing that you're doing for it to be able to say, yep, this is what we're testing it. This is the cabinet. This is how we're, seeing the guy blow up, all that stuff at this range, like all the calculations that go into this is how come we built it this way. This is
yeah,
how come we used this for that.
yeah, definitely. It's got to be right, hasn't it?
Yep.
That's the thing. But no, yeah, definitely a point to progress. But yeah, if there's nothing else in the chat, well, thank you all for coming and bring your. We look forward to getting your feedback around the other bits that we've covered. And if you want to get involved in the next session, let us know.
Sounds
Thanks,
good.
everyone.
Thank you,
Brilliant.
everyone.
Thanks all.
Now I'm gonna shut the chat down now. See you later.